I'm Allison Stiteler, and this is my presentation on chapters 7 to 12. For chapter 7, I'm going to be talking about cloud architecture. So some cloud service models are the on-premise model, and this is where all hardware, software, and everything else is located and managed at the organization's location. And this requires the most work and management done by the customer. So using a pizza analogy, this would be like you're making your own pizza at home. You provide all the ingredients and bake it yourself, and then you eat it at your own table. And then next is infrastructure as a service, and this is hardware services and network infrastructure devices are provided virtually. And an example of this is Amazon's AWS and EC2 or Elastic Compute Cloud. And in the pizza analogy, this would be that you decide the type of pizza you want and the restaurant prepares it for you. Then you take the unbaked pizza home and bake it yourself and eat at your own table. And then you also have platform as a service, and this includes the operating system runtime, libraries, or modules the operating system provides to applications, and the hardware on which the OS runs. And examples of these are GCP and Amazon's Alexa. And Alexa can run the code using PAAS or FAAS. And in the pizza analogy, this is like your delivery option. And for a software as a service, it provides applications. And in the pizza analogy, this would be that the restaurant provides you the crust and all the ingredients, bakes it for you, and then serves it directly at the table that they've provided. And all you have to do in this analogy would be to drive to the restaurant and they clean up after you. And then here's just a diagram of these models, and you can see that on-premise has customer responsibility for almost everything, all the way up to SaaS, which has the least customer responsibility. And for chapter 8, I'm going to talk about segmentation in OT, or operational technology. Segmentation is when a network is segmented into multiple smaller networks and the traffic on one network is separated from another network's traffic, and each network becomes its own broadcast domain. So some of its benefits are that it enhances security. So transmissions and broadcast domains are limited to each network. It also improves performance because segmentations limit the broadcast traffic by decreasing the size of each broadcast domain. And it also simplifies troubleshooting by allowing network admin to narrow down the issue to a smaller network segment. So operational technology is the hardware and software that interacts directly with physical infrastructure and devices through monitoring and control of these systems. So one example of this is SCADA systems, which can monitor anything like HVAC, traffic signals, mass transit in a region, or traffic. And so IT versus OT, they have different priorities. The OT's risks are defined by the physical system's vulnerabilities, so it's a more physical thing in response to interruptions caused by a breach. Whereas in IT, you have that the risks are defined by the exposure of data or availability of services. And IT focuses on business risk, while OT security focuses on physical risk. And OT also relies on east-west traffic, which is difficult to filter and control. And I also just wanted to include this picture, which I thought does a good job of visually showing the main differences between IT and OT. So for chapter 9, I'm going to talk about securing LAN connections. Next, we have firewalls, which are a specialized device or software that selectively filters or blocks traffic between networks. And an example of this in real life could be like a bouncer checking IDs at a club. And so we have network-based firewalls, and these are a firewall placed on the edge of a private network to monitor the connection between it and a public network, such as the internet. And then you also have host-based firewalls, and these only protect the computer on which it's installed. And this also allows for more servers or workstations in their specific configuration, as opposed to a network-based firewall, which has to be configured for all the traffic allowed on the network. So this one's more specific. And the next-gen firewall is a newer firewall system, and it can monitor and limit the traffic of specific applications and adapt to specific users, groups, applications, or devices. And I think this diagram does a good job showing the difference between a network-based firewall and a host-based firewall. So as you can see, the host-based is specific to protecting that device, while the network-based firewall is placed directly between the devices and the internet, and it's shared by the network. And for Chapter 10, I'm going to talk about DOS attacks and malware risks. So DOS attacks, or denial of service attacks, or where legitimate users are unable to access the network resources, and an attacker floods a system with requests, essentially shutting down the network. And in this picture, you can see a DOS attack being carried out with SYN requests flooding the web server. And then a couple types of DOS attacks are a distributed DOS attack, or a DDoS attack. And this uses many sources called zombies. So you can see in the picture, there's all the zombie computers. And there's also DR DOS attacks, and this is a distributed reflection DOS attack. And this is a DDoS attack that bounces off uninfected computers and then is directed at the target, and spoofing source IP addresses to make it appear that all the requests are being sent by the target, which you can see in the picture at the bottom right. You can see the requests bouncing off all of the uninfected computers. So types of malware. Malware is just a general umbrella term that refers to many kinds of malicious software, including the ones I have listed. So a virus is a program that replicates itself with the intent to infect more computers. Trojan horse is a program that disguises itself as something useful but actually harms your system. And a worm is a program that runs independently of other software and travels between computers and across networks. And these can carry viruses. And Trojan horses differ from viruses because they do not replicate themselves. And then worms also differ from viruses because they do not alter the programs, but they can carry viruses. So types of malware, we also have a bot, short for robot, and this is a process that runs automatically without requiring a person to start or stop it. And bots are especially difficult to contain. And we also have ransomware, which is a program that locks a user's data or a computer system until a ransom is paid. And sometimes they'll have an added sense of urgency by showing a countdown clock, which you can see on this one. It's a countdown clock to deletion. So this is an example of the Jigsaw ransomware. Chapter 11, I'll be talking about authentication, authorization, and accounting and network access control. So authentication is the process of verifying a user's or system's credentials to grant access to secured network resources on a system or network. So this is essentially the computer asking, "Who are you?" And some restrictions include the time of day, total time logged on, source addresses, unsuccessful logon attempts, and geographic location. So authorization determines what that entity can or cannot do with the network resources. So this is divided into two categories, and it's the privilege to run, install, and uninstall software, and the permission to read, modify, create, or delete files and folders. So authorization is essentially asking, what are you allowed to do? And the most popular authorization method is RBAC, or role-based access control. And this is where the network admin assigns permissions necessary for users to perform their roles. It groups users associated with the job roles, and each group is assigned specific privileges. And this helps to practice role separation. And for accounting, the accounting system logs an entity's access and activities on the network, and these records are kept in logs and are later audited either internally or by an outside entity. So this is basically asking, what did you do? And then accounting also practices separation of duties, or SOD. This ensures that no one person can single-handedly compromise the security of data, finances, or other resources. And sensitive privileges and responsibilities are distributed to multiple people. And over here you can see an example of the Windows Event Viewer, and it's showing a security audit log. For Chapter 12, I'll talk about plan response and recovery strategies. So some basic terms are an incident, which is any event that has adverse effects on a network's availability or resources. So this could be like a security breach, worms, viruses, environmental issues, such as a fire or a flood. And a disaster is an extreme type of incident involving a network outage that affects more than a single system or limited group of users. And both of these require lots of preparation to have plans and procedures in place should they occur. So with incident response, you have an incident response plan, which defines the characteristics of an event that qualifies as a formal incident, and it also defines the steps that should be followed as a result. This is a 6-stage process, and it begins before the incident occurs. So the first step is preparation. So your response team brainstorms possible incidents and plans procedures for handling them. And step 2 is detection and identification. The systems and staff help recognize the potential incidents, and alerts are escalated based on the company protocols. Step 3 is containment. So the team works to limit the damage, and the affected systems are isolated. And step 4 is remediation, so the team finds what caused the problem and begins to resolve it. And then step 5 is recovery, so the operations return to normal. And step 6 is review, so the team determines what can be learned from the incident and it makes adjustments in preparation for future threats.